This is a short lesson on how to do electron configurations. First off, let's talk about what they are. Electron configurations are addresses for electrons. In fact, you probably saw them in your element project but didn't know what they meant. They tell us exactly where each element's electrons are. And you might be wondering, well, how do we do this? We are going to use the first method. I'm going to teach you two methods. This method is using this orbital filling order to write electron configurations. This is how you read it. You start at the top and follow the arrow. What is the first orbital that you put electrons in? 1s. Then you swing around. What's the second orbital you put electrons in? 2s. Swing around. The next orbital, 2p. Keep going, then you do 3s. Then you swing back and you do 3p. Keep following the arrow. This is where most mistakes are made. You don't jump over to D. You go all the way down here to 4s. Then you do 3d, 4p, and 5s. You just keep following the arrows. So now that you know how to read this, I tell you what, if at this point in time you don't understand what I just said, pause this and bring me over and I will explain it again. But let's say you understand this. I'm going to work some examples. I would tell my class to pick an element, any element, but I'm going to do manganese. Now look at manganese. How many electrons does it have? 25. That's exactly right. We are going to write the electron configuration for 25 electrons in manganese. Okay, so I almost forgot to mention, I do hope you have a copy of this to go along with this video. If not, pause this and go get a copy of this. All right, you got a copy of this. We're going to start at the top and we're going to keep going until we run out of electrons. Now, do you remember the maximum number of electrons you can put in s, p, d, and f orbitals? Sounds like I need to review. Okay, the maximum number of electrons you can put in s is 2. In P, 6. In D, 10. In F, 14. You might be wondering why. Do you remember when we talked about how many M sub L's there were? Well, there was only 0, one number for S. There was a +1, a -1, and a 0 for P. That's 3. You can put 2 in each one, so 6. D is 10 because you have 5 numbers, and then you have 7 numbers for F, so 2 in each, 14. All right, we're going to start here. Here's how I do manganese. 1s. So that's the first orbital I put electrons in. How many can I put in S? 2. I write it as an exponent, but we don't say 1s squared, we say 1s2. What's the next orbital? 2s. Max it out. 2. What's the next orbital? 2p. You can max it out with 6. Okay, we have just found 10 electrons. We have 15 more to go. What's after 2p? 3s. Max it out. What's after 3s? 3p. Max it out. We've now done 18 electrons. We have 7 more to go. What's after 3p? Follow the arrow all the way down, 4s, 2. Okay, so 20. We got 5 to go. What's after 4s? 3d. Now we have 20 electrons already accounted for. Just add the exponents up here at the top. And so we put the remainder. The last orbital always has the remainder, the leftovers, 5. That is an electron configuration. That is an address of where all of manganese's electrons are. And I bet you saw something like this when you did your element project. Okay, I'm going to do another example. I'll do a shorter one this time. Let's do phosphorus. How many electrons does phosphorus have? 15. Okay, first orbital, 1s, 2. Max it out. 2s, 2. 2p, 6. There's 10 electrons, 5 to go. 3s, 2. 3 more electrons left. What's after 3s? 3p. The remainder go here. Probably a good idea if you practice a couple. We'll do some easy ones. Why don't you take a moment and practice and then show me what you've come up with? Why don't you do scandium and silicon? Why don't you do these 2 elements and then come show me? If you're doing okay with these, then you probably can pick up the first assignment, which is a completion grade. I hope this was helpful. Come see me if you have questions.